Hello guys, welcome back to the Training Basket YouTube channel. So in this video, we'll discuss linear regression in detail and then we will look at linear regression code with the help of Python. So now let's start the discussion. So what linear regression is? So it is basically the relationship between independent feature and dependent feature. And if this relationship between independent and dependent feature is linear in nature, then it is called linear regression. Then it is a linear regression problem. We can use linear regression algorithm for solving this particular problem. Now, here we can see in linear regression, if there is a single predictor or we can say single feature, then it is basically your simple linear regression. So we have, let's suppose, y, which is your target variable or dependent variable, and then we have x, which is your feature or independent variable, and we have some points that are populated over here. And if I draw the straight line, so here I can say I am using just a single predictor to predict the dependent variable. So this line is your best fit line. And the equation of this line is y equals to mx plus c. Here my y is dependent variable or target variable. So dependent variable. My m is slope of the line, slope, and my c is intercept. And my x is input. So this is the simple linear regression equation. Okay, so let's suppose initially we have been given x and y. X is your input, y is your dependent variable. So now with the help of x and y, we can find the value of slope. Okay, now let's suppose we have found the value of slope and intercept. Now, if we will be given a new data, then y equals to, let's suppose we have the value of m because we have found with the help of x and y, and let's suppose it is 0.5. So let me just write here 0.5, and let's suppose my new data, this is my new data, and new data is 1. New data, basically it is the value of new data. X, value of x is 1 plus intercept is, let's suppose, 1. So y will be 0.5 into 1 is 0.5, 1.5. This will be the answer. So we need to just find the value of intercept and slope. These two components we have to find with the help of x and y. So this is your simple linear regressions. Let's suppose if we have multiple features, because in real data, in real time problem, we basically get multiple features to predict a single target variable. So in that particular case, what we can do, we have to look at that. So see, this is your multiple linear regression. Multiple linear regression basically means we have multiple predictors, means multiple independent features like x1, x2, x3, x4. With the help of these features, I am trying to find the dependent variable, which is y. Now, the equation of the multiple linear regression is y equals to beta naught, and beta naught is just your coefficient of regression. This is your intercept. It is behaving like an intercept. This is your intercept. This is my intercept. Y is my dependent variable. And beta 1 plus beta 2 plus beta I dot plus beta I. This is my coefficient of regression. This is my coefficient of regression. This is my intercept. This is my dependent variable. So here what we have to do, here also we have to find the coefficient of regression, which is slope. This is my slope. and I have to find the intercept, which is beta naught. Now let's suppose we have slope, your beta naught, beta 1, beta 2, and beta I. So let's suppose I am putting all the values of intercept and coefficient of regression 1 for easy calculation. So 1 plus, this is your 1 into x1 plus 1 into x2 plus 1 into x3 dot 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 1 into xn. So definitely this x1, x2, x3 and xn are your new data points, correct? So if we will put all the values of x1, x2, x3 and xn, we will get the value of y. So as simple as it is. So simply what we have to do, we have to find the coefficient of regression and intercept value. This is my multiple linear regression. Now, we have to basically discuss how it basically works. So let's suppose this is my price and this is your weight of rice. So this is y is basically your price of rice and weight is your weight of rice. Weight of rice. So here, for understanding the working of linear regression, we are using a single predictor, which is weight. So the equation is y equals to m, x is your weight, plus c. Perfect. And y is my price. So if I will find the value of m, so I can draw this line. I can simply draw this line with the help of m, and c, because the equation of a straight line is y equals to mx plus c. And for drawing a straight line, we just need m and c because x we already have. So we can easily draw a best fit line or a straight line. Now, let's suppose we have drawn a straight line. Now, what is our main goal? We have to find the residuals. We have to find the residuals. Residuals, or you can say errors, which is basically the difference between these actual points. These are my actual points. Actual points. And these are the points that are predicted by the equation. This is my predicted points. The difference between these 2 points are my residue. So I have drawn a diagram in the next slide. Let me just go to the next slide. See, this is the diagram. Now, here you can see all the black points. These all are my actual points. These all are my actual points. And I am predicting this particular point here. This is my predicted point. This is my predicted point. And if I'll write the equation of this line, it is y equals to mx plus c. Now the question is, I have told you guys, like we have to find the value of m and c with the help of x and y. And if we find the value of m and c, we can easily calculate the residuals, means errors, which is the difference between actual values and predicted values. So this is the error. This is your residual. Okay. So just look at the formula. This is my formula. Let's suppose this is my x. X is your weight of rice. Okay. And let's suppose it is 1 kg, 2 kg, 3 kg, 4 kg, 5 kg. There are 5 points. So it is like 1, 2, 3, 4, 5. So 1, and here we have to write like 2, 4, 6. So first point is 1 and 2. So here 1, 2, 3, 4, 5. Second point is basically here, and third point is somewhere here, and fourth point is again here, and fifth point is here. So these are my points. So now we have to calculate x2, not x2, it's basically your x square. Okay, so if I'll take the square of 1, it is 1, square of 2, it is 4, square of 3 is 9, square of 4 is 16, square of 5 is 25. Then we have to find the y square value. Square of 2 is 4, square of 4 is 16, square of 5 is 25, square of 4 is 16, square of 5 is 25. Then we have to find the x multiplied by y, which is 1 into 2, which is 4, 2 into 4, 4 into 4, what I am doing? Okay, x into y. 1 into 2, 2, 2 into 4, 8, 3 into 5, 15, 4 into 4, 16, and 5 into 5, 25. So we have found all the values. Now, here we have taken the summation. Now, just look at the formula. This is your linear equation is represented as y equals to mx plus c as we discussed. Now, for calculating m, we are using this particular formula. We have all the values that are being used in this formula. Like we have x in this formula, we have y in this formula, we have x square in this formula. We have, so we can calculate the value of m. Okay, now we have summation square also, means basically addition of all the values of x square. And if we look at intercept formula, this is your intercept. Here also all the terms that are being used in this formula we have already found here, correct? So we can also calculate the value of c. So let's suppose we have calculated m and c. We have calculated m and c. Okay, now we have m and c. Now what we will do, we will calculate the summation of errors, or you can say your cost function. See, formula of cost function is 1 by 2m. M is basically representing number of records. So the formula is 1 by 2m summation. This is for addition. So let's suppose we have 5 values. So it is like 1 by 10 summation 1 to 5, and then y. This is your predicted value. So let's suppose these are the values which will be found with the help of this formula, y equals to mx plus c. We have found the value of m, we have found the value of c, we have x already. So definitely some y value we will be getting, and we are keeping here the value of y, which is your predicted value. Then we will subtract it with the actual value. This is your actual value. Okay, and here I am writing I, here also I am writing I, because this will go till 5. Like first it will go like y1 minus y1, this is your cap, then y2 minus y2, then y3 minus y3, till y5 minus y5, like this. So we are taking the summation of all the values, correct? We are taking summation of all the errors. So let's suppose we have got the cost function, and let's suppose this is x. Now, can we make it 0? What do you think? If we will look at this diagram, can we make all the errors 0? No, it is not possible. Because if I will, let's suppose if I am taking this point, if I'll make error to this point 0, but what about other points? So we cannot make it 0, but we can reduce it, we can minimize it. So we have to reduce the cost function. We have to make it minimum so that it can predict better. Okay. So now for doing this, what we are doing, we are using a gradient descent, and it is basically a optimizer which is used to minimize the cost function, which is your J. Now, the formula of gradient descent is m equals to m minus alpha derivative of loss with respect to slope. Now, we have to understand what this alpha is. This is your learning rate. Now, one question is not clear, and one thing is hovering in our mind. Why this learning rate is required in this formula? So we have to look at it. So let's suppose I am just, this is my loss, this is my slope, this is my slope. Okay. Now, this is your J. Loss means J. And we are getting a bell curve. This is your bell curve. Now, let's suppose I'm just taking here a point. This is my loss. If I want to find a slope here, what I can do, I can draw a tangent. So I can draw a tangent like this. So let's suppose this is my diagram. And if I draw a line like this, definitely if I'll find the slope of this line, it will be negative. So slope of this line will be negative. So slope at this point will be negative. And if I'll take a point here in this direction, so if I'll draw a tangent line, so it will be positive. Why? Because here I'll draw a line like this. Like this. So it will be positive. Correct? Now, let's suppose we have to reduce the cost function. So let's suppose what we can do, we can basically decrease the value of cost function. So it is like this, we are decreasing the cost function, we are decreasing the cost function, we are decreasing the cost function, but we don't know how we can stop this cost function that is moving in the forward direction here, because this is your global minimum. This is my global minima and I have to stop here. Why I have to stop here? Because at this point we have a minimum cost function, or you can say minimum loss. So we have to find this particular point. So basically we have to find the value of slope where my cost function is minimum. Perfect. Now the point is, how can I do it? So simply we can use this formula. So how this formula will be used, that we have to see. So let's suppose here we have taken a value of slope, and let's suppose it is -5. So I am writing -5 equals to, or let's take m equals to -5 minus alpha, which is 0.01, 0.01, and then derivative of loss means -5 with respect to slope. Okay. So here we are taking the derivative of loss with respect to slope. So this -5, if I derive this -5 value, I will get a small negative value. So into small negative value. So it is like -5 minus minus plus 0.01. So here I will get -4.99. So it is approaching to 0. This is my 0. So this is approaching to 0. Okay. Now, let's suppose my m is 5, means positive slope. I am at this point. So here, if I'll apply this formula, m equals to 5 minus 0.01, derivative of loss with respect to slope, it is like small positive value. Why? Because derivative of positive value always will be positive. So it is like m minus 0.01, which is equals to 4.99. Again, it is approaching to 0. Now the question is why we have used a term alpha or learning rate. Let's suppose if I'm using this particular formula, that is m minus derivative of loss with respect to slope. So it is possible that it will shoot my global minima. Why? Because let's suppose if my step size is bigger, if my step size is big, so it is possible that it can overshoot this global minima. But by introducing this alpha term or this learning rate term, what I am doing, I am decreasing the step size, or I am making a step size too small. So it is like this now. So now it will not overshoot the global minima value. And alpha is not your hyperparameter. It is not a hyperparameter value. It is fixed value. It is found by the scientist. So it is a fixed value. So it is 0.01. Okay, perfect. So now let's suppose with the help of gradient descent, we have found the best value of m. Okay, we have found the best value of m and c. So now if we will put these values in this equation, mx plus c, x is your new data. The value of m we have found by using gradient descent, and c also. Now, just look at the diagram. If we will, let's suppose here one child is standing over here and he has this stick, okay, and he is moving this stick in forward and backward direction. So definitely the position will be changed of this line of this stick, and the distance between the actual point and the line will be changed, correct? It will be changed. So basically by using gradient descent, I am changing the value of m. So let's suppose my m is 1. What does it mean? It means if I am changes x by 1 unit, my y is also changed by 1 unit. This is the meaning of slope equals to 1. So if I am changing the value of slope, basically my position of line is being changed in this particular case. So like this, I am reducing the loss. I cannot make it 0, but I can minimize it. So this is basically the working of linear regression algorithm. Now we have understood the theory of linear regression. Now let's look at the practical part of linear regression. So for a practical, we are using a data set and is named advertising.csv. So I am importing pandas as PD for reading the file, import numpy as np. This is used for heavy mathematical calculation. It is an array. So I am running this code. It is run. Perfect. Now pd.read.csv, I am reading advertising.csv file and I am checking top 5 records of it. Perfect. So we are getting unnamed 0, TV, radio, newspaper and sales. So unnamed is not important column for predicting sales. These are my features: TV, radio, newspaper. Features basically means independent variables and sales is my dependent variable. Now, if I'll write the equation of this data set, so it will be y equals to beta naught plus beta 1 TV plus beta 2 radio plus beta 3 newspaper. This will be the equation. So we have to find beta naught, we have to find beta 1, we have to find beta 2, we have to find beta 3. If I will find, or if I will be able to find these 4 values, I will able to predict on new data with the help of linear regression equation or with the help of this equation, which is linear regression equation. Now, let's check the shape of this data set. So this is 200 by 5. It means there are 200 records and 5 columns. Okay. Now, let's check for missing values. So there are no missing values because my focus is on linear regression model. So I have taken a data set where no missing values are present so that I can apply linear regression model. I will feature engineering and EDA is not required in this particular case. So I am splitting my dependent and independent variables, df.ilog. I am taking all the records of the dataset and I am starting from 1. So I am leaving this unnamed 0 because this is not important feature. And I am going till 4. So the index of unnamed is 0, 1, 2, 3, and this is 4. So this will not be included. So if I'll run this and I am putting sales in Y. So Y is my dependent variable. Let's check the top 5 records of X. So it is TV, radio, newspaper, which are my independent features. If I'll check Y, so I will get all the values of sales. Now, what I'm doing here, I am basically splitting my data into train and test so that I can train my model on training data and then test that particular model that have been trained on test data. So from sklearn.model selection, import train test split, xtrain, xtest, ytrain, ytest. You guys have to follow this sequence because this particular function return the 4 values in this order or return the 4 data in this order. So first it returns basically xtrain, then xtest, then ytrain, then ytest. So basically what I am saying here, let me just explain it. Let's suppose we have made a function def calculator cal, and here we have put a and b, and let's suppose add equals to a plus b and multiply equals to a into b. If I'll return add and multiply like a comma b cal 4 comma 5. So in a, value of add will be gone and in b, value of multiply will be gone. So like this, inbuilt function in sklearn is present, which is train test split. So we have to follow this sequence like xtrain, xtest, ytrain, ytest. So here what we have done, we have used this function. This is your independent variable, this is dependent variable, and we are putting test size equals to 0.10. It means we have 200 records. So we have keeping 10% of 200 in test data set. Random state equals to 34. So if I'll run this F and if I'll check the shape of training data, it will be 90% of 200 records because we have kept 0.9 for training data because 1 minus 0.1 is 0.9. If I'll check for X test, it will be 20. 20 records are there. And X dot shape is 200, comma 3. So here I am using a sklearn library. In sklearn, a linear model module is present. Inside of linear model, we have one class linear regression. We are creating an object of linear regression class, and then we are using a function, a method, and its name is fit. So we are doing lr.fit xtrain ytrain. Now I have run the code. Now it has found the value of beta naught, the value of beta 1, the value of beta 2, and beta 3. So let's check all these 4 values. See, this is my intercept, basically your beta naught. So this is 2.81. We have found this value. Okay, let's check the coefficient. Coefficient basically means coefficient of regression. So B1, beta 1, beta 2, and beta 3. It will give me 3 values. See, it is giving 3 values. So 0.0463859, 0.119, and minus 0.003. So this is my metrics for checking the accuracy. So from sklearn.metrics, import r square, ypred equals to lr.predict xtest, r2 score, ytest comma ypred. So if I'll run this code, I will get the accuracy of this particular linear regression model. Let's suppose I have found the beta naught, beta 1, beta 2, and beta 3, basically your coefficient of regression and intercept. So let's predict our new data. So let's suppose this is my output equals to my object of linear regression is LR. So LR dot predict, and then let's suppose if I'll give a 1D array, it will give me an array. So 1, 2, 3, 1, 2, 2, and then 34, and then $23. So I am spending $22 on TV, and then $34 on radio, and $23 on newspaper. Now it will give me error. Let's check output. See, it is giving an error. Why? Because this predict method takes a 2D data. So I have to put one more square bracket here and here. I'll run this code. I am getting 14.90, which is my Y, or you can say sales. So this is all about linear regression topic. If you guys have any doubt related to linear regression, you guys can mention your questions in the comment section below.